Hello and welcome to the session. Today's session will discuss about machine learning and importance of probability and statistics with respect to machine learning. So when you are learning machine learning, then it's very important that you also study about a little bit of math, especially statistics and probability. In fact, you can say that statistics is the heart of machine learning. Let's understand what's statistics and probability. So statistics is actually a powerful tool which is used for making sense of the data, and it is the core that lies where lies the concept of distribution. We will also discuss in this session. We'll be discussing mainly in detail about the probability density. So basically, what is probability density? With respect to that, there we are going to see a lot of distribution curves. So distribution in statistics basically helps us to comprehend the way data is spread out. So machine learning largely involves forming hypotheses for constructing a model, evaluation of the model using the hypothesis testing, and construction of data sets where again you use sampling theory. So this session, let's unravel the diverse types of distributions. Let's have a clear understanding of these characteristics. Let's understand the applications and significance of statistical analysis. So let's begin with probability distribution. Now, probability distribution for a variable x basically summarizes the probability which is associated with x's event, whereas distribution is a parameterized mathematical function. It gives a relationship between the observations in a sample space. So this function we can use to calculate the probability of an individual observation. Now, two types of probability distribution are there: discrete probability distribution and continuous probability distribution. So this session we will learn in detail these two distributions. And also we will come across these terms when we are discussing these probability distributions. One is PDF and the other one is CDF. PDF stands for probability density function, which is used to calculate the probability of observing an instance, whereas cumulative distributive function or CDF computes the probability of an observation which is less than or equal to the value. So continuous probability distribution basically gives a relationship between the continuous random variables and their probabilities. So we will be seeing a lot of plots of PDF, that is probability density function, across the different types of continuous and as well as in discrete probability distribution. Now both of this PDF probability distribution function as well as cumulative distribution function have continuous values. Suppose you have discrete values, then we call it as PMF, that is probability mass function. It is basically a discrete equivalent of probability density function. Okay, so PDF and CDF are continuous values. Now if you have a discrete value, then we call it as PMF, that is probability mass function. Okay, and what is CDF? CDF computes the probability of an observation less than or equal to equal to the value. So it's a probability of an event that cannot be detected directly. So basically we compute it as an area under curve for some intervals. So let's understand now these two probability distributions in detail. Coming to the machine learning, now these are the two important distributions we will come across in machine learning: continuous probability distribution and discrete probability distribution. In continuous probability distribution we have three types: normal distribution or rectangular, also called as uniform distribution, and the third one is exponential distribution. The discrete distribution has three types again: binomial, Poisson and Bernoulli. So these are the distributions, how it looks like. This is the normal distribution. It looks like a bell-shaped curve. This is an exponential distribution, and this is a uniform distribution. And this is how the curves of discrete distribution looks like. Since they are discrete values, you can see you have the discrete values here. This is a binomial distribution, this is a Poisson distribution, and this is the last one, that is the Bernoulli distribution. Now let's begin with the first one. So we will discuss now each one in detail. Let's discuss now the first continuous probability distribution, that is normal distribution. Now when the word normal distribution comes, please keep in mind it is a continuous probability distribution. Okay, and this should strike into your mind. First, when I say normal distribution, the graph should come into your mind of a bell-shaped curve. So you should get the picture of a bell-shaped curve when I say normal distribution, or it is also called as Gaussian distribution. And this is actually one of the most common distribution function. Okay, so as I said, the shape is very important. The shape of the distribution in normal is typical bell-shaped curve. So what does it mean? Since it is a bell shape, the data will tends to be around the central value, and there is no bias towards the left or the right. So that's about normal distribution. Okay, now as I discussed just now, PDF, that is probability density function for a normal distribution, how can it be used, right? So this is how the probability distribution function will be. This is the probability distribution function of a normal distribution. As I told you, it is a bell-shaped curve, and as I told you, the values will be centered around the mean, and there will be no bias towards the left or the right. Now coming back to the applications, now we can use normal distribution in various cases. I can use it for making a distribution of the heights of the students. I take a class, I take the heights of all the students, and I can represent this distribution in the form of a normal distribution, or the blood pressure of a population, or the marks scored in a class. So these are some of the applications. Coming to the characteristics of normal distribution, in this case the mean, median, mode are all equal. Okay, and as I told you, most data points will cluster around the mean, that is at the center of the bell-shaped curve, and the data values near the mean are more frequent than those from the mean. So as I showed you in this graph, the mean value will be centered here, so data is actually clustered over here. Okay, now coming back to the PDF of the normal distribution, the probability density function equation is like this: f of x comma mu comma sigma square is equal to 1 by root of 2 pi sigma square e to the power of minus of x minus mu whole square divided by 2 sigma square, where mu is the mean and sigma is the standard deviation. So remember this, in normal distribution there are two parameters, or two, which is very important: the mean and the standard deviation. Okay, so this is how you write the probability distribution function of a normal distribution. And if you want to normalize the data, we have discussed about z-score normalization in other sessions. So if you want to normalize the data, what you do is, for that variable, every variable you subtract with mu and divide it by the standard deviation. So you get the z-score for that variable x. Okay, now coming to the normal distribution for different means. So as you can see in this curve, see, understanding the properties of normal distribution means that you are using some kind of inferential statistics to compare different groups and making estimates about population. So basically we are making some kind of comparisons about with different groups. So if you see, this is a normal distribution curve which I'm going to compare with this one as well as this one, and as you can see that here the mean is around 900, here the mean is around 1100, and in this case the mean is around 1300. So what we observe here is the normal distribution just moves to the right as the mean value increases, or you can say normal distribution moves to the left as the mean value decreases. So basically you use the normal distribution to make a comparison between the different groups. And not just that, this is a normal distribution with different means comparison. You can also compare it with different standard deviations. So standard deviation is basically the width of the bell curve. Okay, so this is the width. So width is basically our standard deviation here. So you can see that standard deviation 80 will have a taller peak, and it is a narrower bell curve, whereas standard deviation with a value of 190 is a very broader bell curve. So as the basically you can see that the standard deviation, as a standard deviation increases, the bell curve also stretches. So it results in a wider curve. So this is a comparison of normal distribution with respect to the standard deviation. So basically the properties of normal distribution is very well understood if you are comparing it with different groups and making some kind of estimates about its sample. So this is a comparison with respect to mean, and this is with respect to standard deviation. So that is why, remember this, normal distribution is a bell-shaped curve, and there are two variables here, mean and standard deviation. And how to calculate PDF of this is, PDF, that is the probability density function of normal distribution, is this concept. This is a formula. So now coming to the next distribution, next continuous distribution, that is a rectangular or uniform distribution. As a word itself says, this is a uniform distribution. Now if you want me to compare the previous normal distribution with a rectangular distribution, what we saw in normal distribution was it was bell shaped with most outcomes which were clustered around the mean. Whereas in rectangular, all the outcomes will be equally likely, it will occur. All the outcomes will occur equally. So if you actually observe the graph, that would be more convenient to understand. So you can see here, this is a representation of the rectangular or the uniform distribution. As you can see here, all the events are occurring equally. Whereas in normal, what happened? The data was centered around the mean value. But here it is not like that, right? All the events are occurring simultaneously, equally. They're equally likely it will occur. So basically, suppose I have two parameters x and y, where let's say a is minimum value, b is maximum value, or let's say there are two parameters a and b. A is the minimum value, b is the maximum value. So this is how the uniform distribution will look like. It will start from a and it will go on up to b, and you can see that all the data are equally likely occurring between these values a and b. Okay, so this is the distribution of the uniform distribution. It's also called as a rectangular distribution, where all the outcomes or values within this range of a and b are occurring equally. And this is the probability distribution function, PDF of the uniform distribution. What we can say is P of x is equal to 1 by b minus a for all the values of x ranging between a and b. Otherwise it is 0, right? It is 0 here. And here it is 1 by b minus a. Now coming to exponential distribution, now this is a graph of the exponential distribution. So basically this is used to describe the time between the events, okay, in a Poisson process. So it's used to describe the time between the events. We also say that exponential distribution is a special, there is one more distribution called as gamma. Exponential is a special case of gamma distribution with fixed parameter I. We are not discussing about gamma in this session. So this is the representation of the exponential distribution. As you can see here, there are there is only one parameter which is important, that is lambda over here. Okay, so f of so the probability distribution function for a variable, random variable x, is lambda into e power of minus lambda x for all the values of x greater than or equal to 0, and it will have no negative value. So that means the value will be 0 if x is less than 0. So that means if this is x, here we don't have any values in the negative, but on the right hand side, that is in the positive values of x, you will see, you will get a exponential. This is a exponential curve. So that is, what is the value? Lambda e power of minus lambda x. That's why you can see that the exponent is falling like this. Okay, and what you can observe here is when the lambda value is 1, this is for lambda value 1 and this is for lambda value 2. You can see that this is how the curve changes. So mean and standard deviation, if you want to calculate for the exponential distribution, then we can say that beta is equal to 1 by lambda. So 1 by lambda is the value, is a parameter we can use for calculating the mean and standard deviation using the lambda. So basically in exponential distribution, it's a process where the events will happen continuously and independently at a constant average rate. And applications of exponential distribution where you can use this, you can for the case studies of supermarket, where the amount of money which is spent by a customer on one trip to the supermarket will follow an exponential distribution. So basically exponential distribution graph is a graph of PDF, that is probability density function, which shows a distribution of distance or time taken between the events. Okay, so exponential distribution will demonstrate, or it will show the distribution of distance or the time taken between the events. So if you talk about supermarket, one trip to the supermarket is a time. So how much of money spent, suppose, in one trip, that is an exponential distribution that can be represented using an exponential distribution. And as I told you, there are two important values here, lambda and x. So lambda basically it represents the event per unit time, and x is actually the time. So this is x, this is lambda. So x represents the time and lambda represents the event per unit time. So you can see this graph, right? The two different graphs. So lambda is equal to 1 and 2. Now coming to the next one, discrete distribution. Now under this again we have three types: binomial, Poisson and Bernoulli distribution. Coming to the Bernoulli distribution, binomial distribution, also called as Bernoulli trail, as the word itself says this is binomial. So that means there are only two outcomes. Either you will have a success or a failure. Okay, so what is the goal of binomial distribution? To find the probability of getting success k out of n trials. Okay, so that is the goal. So what is a method? The method to get success out of k out of n number of trials is this. Okay, so the method to get success k out of n trials is n factorial divided by k factorial into n minus k factorial, where k is the success k, n is the total number of trials, k is the number of success in n, and number of failures will be obviously n minus k. So probability of success in a certain number of trials is like this. P power, this p is the probability, so p power of k into 1 minus p power of n minus k. Naturally, right? Because k is the success, n minus k is the failures. So p is the probability of getting success, so p power of k into 1 minus p is the probability of getting failures to the power of n minus k. Okay, so p is the probability of success, 1 minus p is the probability of failure. So combining both of these equations, the probability density function of the binomial distribution is like this. So we are combining this equation and this equation. So what do you get is nk into p power of k into 1 minus p to the power of n minus k. So this is the probability density function or the PDF of the binomial distribution, which we got by combining this equation and this equation. Okay, where k is the number of choices of success, n is the total number of choices, and p is the probability of each choice. So if you want to calculate the mean of the binomial distribution, then that is nothing but mu is nothing but n into p. And if you want to calculate the variance, sigma square is equal to np into 1 minus p. And if you want to calculate the standard deviation, then sigma is equal to the same thing, just take the square root. Standard deviation is what? It is nothing but square root of variance. Okay, so this is how you can calculate the mean, variance and standard deviation of a binomial distribution. Now an application of binomial distribution is, you can take all kinds of applications where you can just have two outcomes, success or a failure. And one good example is tossing a coin, right? Suppose I say that getting a head is a success. So it need not be, just say that if I want to say getting a head is a success, then suppose I am tossing the coin 10 times. So the probability of getting exactly 5 heads would be how much? So n is equal to 10 is the number of trials, right? And what is the probability of success? Probability of success is 0.5, right? So this is an example of binomial distribution where you just have 0.5, right? Probability of getting head is 0.5, probability of getting tail is 0.5. Now coming to the next one, Poisson distribution. Now Poisson distribution is also a discrete probability distribution. Now here Poisson distribution gives a probability of an event happening a certain number of times within a given interval of time or space. Okay, so Poisson distribution, it has only one parameter, it has lambda, which is the mean or the mean number of events. And Poisson distribution often appropriate for count data. Where we can use it is wherever we have applications where we can count the data. For example, I can count the number of emails received. So such case I can put Poisson distribution. I can count the number of customers visiting a shop. So there I can use the Poisson distribution. I can get the number, count the number of phone calls received by an office. So here I can use the Poisson distribution. Using Poisson distribution for these applications, I can get the probability of an event which is happening, right? How many number of times within that time space, right? So using Poisson distribution, suppose I want to apply Poisson distribution for number of emails received. What will I actually get? I will get the probability of the event, how many times I'm receiving the mail, that would be k, for a given time space. And again, the PDF of Poisson distribution is represented like this. Okay, here also we have just very important parameters, that is lambda. So probability of an event, that event occurring, that is x. So that will be e power of minus lambda, lambda power of x by x factorial. So here lambda is actually the mean rule, which is inclusive of the previous events. X is the number of times the event happens, okay, and lambda is the mean number of times an event will happen. Okay, x is the number of times the event occurs and lambda is the mean number of times an event occurs. So this is the graph, right, which will show the Poisson distributions. So as I go on changing the lambda value, I can see that the Poisson distribution will change, right? What is lambda? Mean number of times an event occurs. So as you can see here is, here lambda is equal to 0.5, here is it's like this. The Poisson distribution looks like this. For lambda is equal to 1, the Poisson distribution is like this. Lambda is equal to 2, you have like this, right? So as you can see that it goes on decreasing like this. As the mean number of times an event occurs, the Poisson distribution is slowly changing, and it's a discrete distribution, right? So that's why these points are plotted. So this graph actually shows an example of Poisson distribution with different values of lambda. So what you have to remember here is very important key points is it's a discrete probability function where we are plotting or where it is actually providing us the probability of an event happening, right, a certain number of times within a interval of time space. So certain number of times is nothing but k, that is this. So these are the events happening. These dots are actually the events happening within this time space. So that probability I have plotted in the y-axis. Okay, so that is why this is a probability density distribution of the Poisson distribution, where we are plotting the events which are happening within a given time space. And as the lambda value is increasing, that is mean number of times the events are occurring, you can see the graph is changing like this. Here number of events occurred is very less in the yellow one, and in this one the number of events occurred is more. You can easily plot it like this. So coming to the next one, Bernoulli distribution. Now Bernoulli distribution is also a case of discrete probability distribution, but here what's the difference here is the Bernoulli random variable can only have again two outcomes here, 0 and 1, where and p will represent the probability of success and 1 minus p will represent the probability of failure. And here also we can calculate the mean and variance. The mean of probability distribution is E of x is equal to p and variance is p into 1 minus p. So basically this distribution model will experiment whose outcome will be binary. Again here, just like binomial distribution, Bernoulli distribution also is also used for experiments or for models where the outcome is only binary, right? Outcome is positive with p and negative with p minus 1. So what are the applications? So you can think of applications again where you just have two choices. For example, tossing a coin, passing or failing, winning or losing, yes or no. See, these are all applications where you can use. And one simple example is when flipping a coin, right? It can land on either heads representing success, or tails, let's say, which indicates failure. So what is the likelihood of achieving head is p. What is the likelihood of getting tail is 1 minus p. Okay, and this is the that's why we, since these are discrete values, we will call it as probability mass function. So probability mass function for this distribution is q, that is 1 minus p if k is equal to 0, p if k is equal to 1. And here again we calculate the mean. The mean is nothing but p and the variance is nothing but p into 1 minus p. So that's it for the today's session. So today's session we had a quick revision of all the probability distribution functions like continuous distribution and discrete distribution. Any doubts, please write to me in the comment box, and please subscribe to the channel. Thank you so much.